All right, you're an astronaut. I don't know how you did it before you finished your physics class, but in this problem, you're an astronaut, you're in deep space, and you've got yourself a spring that you brought from home, one of your springs. You know it's K constant, okay? And you've got this thing that you want to you want to weigh it, right? You've got some doodad here. You want to know its mass. But, well, a scale won't work, and a triple beam balance won't work, because you're in deep space and there's no gravity to pull this thing down. So you can't really weigh it in any sense that we're used to. But what you do is you go ahead and attach this mass to your spring, your favorite spring, and you pull it back and start it oscillating back and forth, right? So it's going to go boing. So you watch this oscillation and you observe what the period is. You know that the period is, so let's get some numbers going here. You see that the period is 3 seconds, and let's say the K constant for this spring is 500 newtons per meter. So we're supposed to be able to figure out the mass based on this information. So this is a simple harmonic motion problem, actually. There are a few ways that you could measure the mass of something without a scale or gravity. This is one of them, maybe one of the more crazy ones. We know that the period of a spring and a mass oscillator thing is 2 pi root m over k. All right, so we know the k and we know the period, so we can solve for the mass. That's actually a very simple problem, but it is one that if you didn't think about these things beforehand, that you could lose points on a test or something, even though it's a very easy one. But like, what am I doing with a mass and a spring in space floating around? I don't know. But this is how we relate these things, right? And I suppose the biggest hint is the fact that they give you the period of oscillation. So you know that the period of oscillation in the context of a spring is this, and it's just a matter of solving for m. So we get t squared over 4 pi squared times k, I think if I did that right, is equal to m. And there you go. Let's see. So that's, do I feel like doing this? 9 over 4 pi squared times 500. Pi squared is, I don't know, something like 9, so those would cancel, and we have something like 500 divided by 4, ish. But that's your answer symbolically, which is the one I like.